Have you ever stopped to think about how you find one tiny piece of information in, well, a whole universe of data? It's not magic, not at all. It's actually a science, an art form, really, that started out in the back of a book, and now it literally powers the entire internet. Today, we're going to pull back the curtain on indexing, the hidden system that organizes our world.
So here's how we're going to break it all down. First, we'll tackle the huge problem of just organizing stuff. Then we'll look at two totally different philosophies for how to do that. We'll see how these ideas played out before computers, what happened when they took over, and finally, how all this history is shaping the very future of how we find anything.
All right, let's start with the big one. We are swimming in an ocean of information that's getting deeper every single second. But honestly, without a way to navigate it, it's all just noise. So how do we find the signal in all that static?
Really think about it. Imagine you walk into the biggest library you've ever seen, but there's no catalog, no signs, nothing. And you're not looking for a book title, you're looking for one specific idea. Where would you even start? This exact overwhelming problem is why indexing was invented in the first place. So at its heart, an index is just a map. You know that index in the back of your old science textbook? The one that told you photosynthesis is on page 42? It's that, but on a massive scale. It's a pointer that says, hey, the thing you're looking for, it's right over here. And yeah, it all began with that simple but totally brilliant back-of-the-book index. So as people started making these information maps, they pretty quickly realized there were two very different ways to draw them. And this split in thinking, this fork in the road, it basically defines every single search system we use today.
And here's that big split. On one side, you have derivative indexing. This is where you literally just pull words, the author's own words right out of the text. It's automatic. It's literal. But on the other side, you have assigned indexing. This is where a human expert reads the document, understands the concepts, and then assigns terms from a standardized, pre-approved list. This is all about human interpretation, about making sure everything is consistent.
Okay, let's dive into that first philosophy. We'll call this the think ahead method, where the whole goal is to predict what you're going to be looking for long before you even type a single word.
And this is exactly what pre-coordinate means. The indexer doesn't just make a list of keywords. No, they build relationships between ideas right from the very beginning. They combine or coordinate different concepts into these structured phrases, basically trying to guess the complex questions you might ask down the road.
A fantastic example of this is a system called chain indexing. It was developed by this absolute genius of a librarian, S.R. Ranganathan. And you can see from his quote, he saw it as a really systematic, almost mechanical process for breaking down a big topic into a chain of smaller connected ideas.
So here's how it actually works. First, the indexer gives the subject a classification number. Then, they break that number down into what they call a chain of concepts, from the biggest idea to the smallest. The really clever part is step 3. They figure out which parts of that chain someone is actually likely to search for, and those become the index entries.
Let's make this concrete. Say we've got a document about researches on child psychology in India. A librarian using this system would build that concept up, starting with the broadest topic, psychology, and getting more and more specific.
And check out what this system does automatically. It spits out all these different entry points. So you could search for the whole super specific topic, or maybe you just start by looking for child psychology, or even just psychology. The system creates all these pathways for you, so it doesn't matter how broad or narrow your search is, you're going to find it.
All right, now let's just flip that whole idea on its head. What if, instead of having the indexer do all that hard work up front, we just give all the power to the person doing the searching? And the key difference, the whole ballgame, is when the ideas get combined. With pre-coordination, it happens at the beginning at the input stage. It's locked in, it's rigid. But with post-coordination, it happens at the end, at the search stage. You, the user, get all the flexibility to mix and match terms however you want.
The big pioneer of this approach was a guy named Mortimer Tobey, and his system was called Uniterm. The idea was so simple, it was revolutionary. Just break everything down into its single most basic concepts, its uniterms, and then index every single one of those terms separately. The document isn't about child psychology, it's about child and psychology. But that freedom came with a huge and super annoying new problem, the false drop. If you just search for the separate words evaluation, teachers, and students, the system has no idea how they're related. It just sees that all three words are there and gives you everything, including stuff that's the exact opposite of what you want. The meaning, the context is totally lost.
So to fix this, indexers had to get really clever. They came up with tricks like links, which were basically codes to tie related terms together. They created roles to say what a word was doing, like is steel the thing being made or the tool used to make something else. And they used weighting to show how important a term was in a document. It was all about trying to stuff that lost context back into the system.
So you have this constant battle, right? Structure versus flexibility, context versus keywords. And this whole debate set the stage perfectly for the biggest game changer in the history of information, the computer.
I mean, look at this timeline. You can see almost 100 years of people just grinding it out, trying to figure this out. But then look at the end there. Things start to accelerate like crazy. Just 5 years after Taube came up with Uniterm, a guy named Hans Peter Lund at IBM let the computer loose on the problem, and everything changed.
Lund's invention was called KWIC, which stands for Keyword in Context, and it was basically derivative indexing on steroids. The computer would just scan a title, use a stop word list to ignore boring words like the or of, and then it would automatically create an index entry for every single important word. But, and this is the key part, it kept the words around it to give you context. And this is what it looked like. You take a title, like Chemical Treatment of Cancer in the Hospitals of Chennai, and the computer just rotates it for every key word. See how all the main words are lined up in the middle? You could just scan down that column with your eye, find your term, and immediately see the context it came from. It was ridiculously fast, totally automatic, and an absolute revolution.
So, okay, a cool system from 1958, why are we still talking about it? Because those fundamental arguments, that fight between human-assigned concepts and machine-extracted keywords, are the very foundation of how we find things on the web right now.
Just think about it for a second. When you fire up a giant search engine, you're using a direct descendant of KWIC indexing. It's automated, it's keyword-based. But when you browse a carefully curated website or a library database, that's assigned indexing. A human expert picked those things for you. And this whole dream of the semantic web, that's just the modern version of trying to solve that old false drop problem. It's about trying to teach computers what words actually mean.
And that leaves us with one last really big question. You see, all those early pioneers of indexing, they were obsessed with one thing, accurately representing what was inside a document. But today, as AI starts pumping out endless amounts of content, the next great challenge isn't just going to be finding information. It's going to be indexing for truth. How on earth are we going to do that? Well, that's a question for the next generation of indexers to solve.